Hey everyone, I hope you're having a wonderful day so far. My name is Alyssa and I'm here with another amazing experiment for you. It's another chemical reaction one, but this time we're going to see how acids and bases work. Another fun question I have you before we start this experiment is there a way we can blow up a balloon without using our mouth to blow it up? We're going to find out after we go over some background information and before we jump into our experiments. Ready? All right, here we go. All right, so our experiment we are going to be doing today is called balloon magic. Ooh. So before we jump into the experiment, let's go over some definitions and some terms we're going to need in order to complete our experiment. Now, in order to get this experiment to work, we need to know what a chemical reaction is, which is a process in which one or more substance, the reactants, are converted to one or more different substances, or the products. An acid is a substance that tastes sour, reacts with metals and carbonates, and turns litmus paper red. A base is a substance that tastes bitter, feels slippery, and turns litmus paper blue. pH scale is a tool used by scientists to measure how acidic or basic a liquid is. Now, breaking that down a little further, acids is a substance that can donate a hydrogen ion, generally a proton, to another substance. So in order for a substance to be considered an acid, it has to have hydrogen in it. Lower pH level of 7, so looking at the pH scale, anything lower than a 7 is going to be considered an acid. So pH values of 4 to 6 are generally considered weaker acids, and pH values level ranging from 1 to 3 are generally stronger acids. Acids have been known to corrode metals and skin. They can also conduct electricity. And a base is also an acid's chemical opposite. Bases are a substance that can accept a hydrogen atom from another substance, and they usually have a lot of hydroxide ions. Also, looking at that pH scale we defined on the first slide, a base is going to be considered or have a pH level greater than 7. So anything with a pH value of 7 to 9 are generally weaker bases, and a pH value greater than 9, so like 9 to 14, generally are strong bases. Bases can be neutralized by acids, and acids can also be neutralized by bases because they're chemical opposites. And generally, for most reactions to occur, the acids and bases are present in the experiment are not in equal amounts, and the imbalance between the acid and the base is usually what allows the chemical reaction to occur, whether it's on a small scale or on a larger scale. Now, where do we find acids and bases in everyday life? So think of something you might have had for breakfast this morning, like an orange or another kind of citrus fruit. That would be considered acidic or fall in the acid category. Another form would be hydrochloric acid, which is in the stomach that actually digests food. Muscles producing lactic acid after we run around and exercise outside, that's considered an acid. Also, regular vinegar in the kitchen is an acid. Looking at bases, your pancreas actually uses alkali, which is a base to help with digestion and breaking down food. Ammonia is another common base. Caustic soda or drain cleaner made from sodium hydroxide is also a base. The sodium hydroxide is the main component to consider that a base. And also baking soda is one of the most common bases we have in our kitchen every day. So for our balloon magic or magic balloon experiment, the materials we're going to need to complete are baking soda, vinegar, empty water bottle or an empty water bottles, depending on how many times you want to do the reaction or if you want to try different measurements of the baking soda and the vinegar. We're going to need a balloon or multiple balloons if you're doing it a few different times, a funnel, or if you have 2 on hand, that's awesome, and some measuring spoons. Gathered all these materials, we're going to be ready to start our experiment. So let's get ready and jump right into our experiment. Here we go. Alright guys, so I have gathered all of my materials for the experiment in my kitchen. Excuse me, sorry. I am probably going to end up using just a regular Poland Springs water bottle. This might actually be one of the teas I drank earlier today. Balloons I got from the Target dollar section. The dollar store probably also has a couple bags of balloons as well. Before you start grabbing the materials, double check with mom and dad that it's okay that we're able to do this experiment. Better yet, have them jump in and do the experiment with you. That way you guys can both see the reaction. All right, so what I'm going to do, I'm going to end up taking my funnel, and then I am going to end up placing it into the end of the balloon. So once you have that, I'm probably going to hold mine. So it's going to look a little wonky like that. So once we have that all set, we are going to then take our baking soda. I put a piece of paper towel down so I wouldn't make a giant mess, because that's what I tend to do sometimes. And we need to take about 4 to 6 teaspoons. So grab one of your measuring cups, and then you are going to carefully scoop the baking soda out. And then place it in the funnel so it all goes into the balloon. So I'm probably going to do 5 scoops of the baking soda. You are more than welcome to add as much or as little as you like. The recommendation was 4 to 6. So whatever you feel most comfortable with. The more baking soda you add, the probably larger reaction you'll have. That's 3. 4. And then 1 more for good luck. All right. And then 5. All right. So I have all my baking soda in the balloon. Once I am done with that, I am going to carefully remove the balloon from the funnel. I'm now going to put my funnel in my water bottle. And then I'm now going to take my vinegar, just using regular white vinegar that's in my kitchen. And I'm going to pour about a 1/3 cup of vinegar in. They said about a 1/3. Again, you can use as much or as little as you would like. Carefully pour this in. All right. Once we have that, set that off to the side. Move the vinegar out of the way. We'll take our funnel out of the bottle. Now, this part is the next part. It's going to be a little tricky to do. So we want to put our balloon and have it seal over the water bottle, but we don't want to dump the baking soda in quite yet. So again, it's going to look pretty funky right now. I'm wondering if I should do more vinegar. So just looking at mine, I'm going to add just a little bit more vinegar to it. I'm going to go off the charts and free pour my vinegar. It's completely up to you how much or how little you want of each. We'll see how this reaction does. And then we can adjust from there. All right, so I'm, again, going to pull the funnel out. I'm going to carefully take my balloon with the baking soda in it. Oh, goodness, that could have been bad. I'm going to put it over the lip of the bottle. And now, here's the super fun part. We are going to carefully take our balloon. We're going to flip it over so we can add our baking soda. Whoa! Do you see that? Look how cool that is. It's blowing the balloon up. Do you see how it was fizzing and bubbling and it made the balloon go big? That is incredible. How fun is that? So, looking at this experiment, did it react the way you thought it was going to act? I know these ingredients are very commonly used when you do like a baking soda volcano. There's also a few other baking soda vinegar experiments out there as well. So, when we're doing this, when the baking soda hits the vinegar, it ends up creating a chemical reaction that produces carbon dioxide, which then blows the balloon up because the air has nowhere else to go. And then the carbon dioxide is actually what inflates the balloon. So you just learned something that you could do a chemical reaction every time you have to inflate balloons. How cool is that? So I'm curious to hear how your results went. Were you expecting that the balloon would blow up with the reaction from the vinegar and the baking soda? Did it get as large as you thought it would be, or was it a lot smaller than you thought? Did you have a lot of fun doing the experiment? Let me know in the comments, and if you have any questions about acids and bases and chemical reactions, hit me up and maybe we can keep doing more experiments like this one. All right, guys, have a wonderful rest of your day, and I'll talk to you soon. Bye!